We had to solve this problem showing the work. A plane is headed due north with a near speed of 210 miles per hour. So as we read, we'll keep on making the vectors as well because they're talking about velocities. So this is where the plane is. It's going in south definitely at 210 miles per hour. Then the wind is blowing 20 miles per hour, which is 30-degree west from as measured from south. So west is over here. So a west from south is like this. So this is 30 degrees and this is 20 miles. Really, the vector will not be, the length will not be that much because the length actually determines the magnitude. So against 210, 20 is a very small vector. It is over here. We need to find the resultant ground speed in the direction of the plane to the nearest whole number. Always a great idea to make the components of this 20 along the velocity of the plane and perpendicular to the velocity of the plane. So that's going to be 210 remains as it is. 20 will become 20 cosine of 30 degrees, and this will become 20 sine of 30 degrees. And since we need to find the resultant of these two vectors, which is, let's say, somewhere over here, and since the two vectors are at 90 degrees, definitely their resultant will be using the Pythagoras theorem. So the resultant is going to be square root of x component square, which is 20 sine 30 degrees square, plus y component square, which is 210 plus 20 cosine of 30 degrees whole square. So that is going to be 20 sine 30 square. I'm just using my calculator, plus 210 plus 20 cosine of 30 square, and the square root of this value is 24 point 1 second, I need some correction. That's square plus 210 plus 20 cosine of 30 square. The square root of this value is 227.54, so close to the nearest integer, that's 228 miles per hour. And as far as the angle is concerned with respect to south, the angle is this, and this angle can be easily found by writing tan alpha as the opposite, which is the x component, because these two are going to be same. In this particular triangle, this length and this length is going to be same. So that's why I write 20 sine of 30 as the opposite over the adjacent. So adjacent in this particular triangle is going to be this length, which is this. So that's going to be 210 plus 20 cosine of 30. So if I take tan inverse of both sides, I'm getting alpha is close to 3 degrees. So clearly the correct choice will be option number D. Thank you.